I worked on electrical distribution network in one of my company. So my company was responsible to draw the electrical distribution network on GIS. Workflow was there were some teams deployed on site to collect the electrical distribution network. The physical location, they were using GIS and GPS and total station to collect the X and Y coordinate of the equipments involved in network, as well as the descriptive information. Information they were collecting by the nameplates. So this collected data was transferred to my office, and my team was responsible to draw the electrical distribution network. Since then, I was thinking to automate one process that we did manually that time. And the process is to connect the meters, electrical distribution points to the concerned feeder. For example, this feeder, this line, as you can see, is feeder number 4. As you can see, the label is substation, so it's a substation for feeder number 4. This line belongs to substation 1, feeder number 4. This line, this feeder is feeder number 4 of substation number 1. And here are the electrical distribution points. You can see the some label is also there. So for example, this point is feeder 4, substation 4, feeder 4. This point is substation 4, feeder 4. This one is substation 1, feeder 4. This one is substation 1, feeder 4. So this point, substation 1, feeder 4, should be connected to substation 1, feeder 4. So we have two segments of cable, segments of line. This one and this one. This both belongs to, I will highlight and show to you this point, this line and this line. This both lines belongs to substation number 1, feeder number 4. And this one service and this one, the two services, they belongs to the same feeder. So this connected to this or this, and this substation 4 feeder 4, substation 4 feeder 4 should be connected here. So we can do manually also. Right now on your screen there are only 4 points, so we can connect manually, and just it will take 5 or 6 minutes. But suppose, because every substation, mostly it depends on the capacity power of the substation, in terms of kVA, that how many services will be fed on it, and as well as plus kVA power of the substation, and plus the type size of the cutout installed on the individual houses. So this both things, two things decide that how many services can be connected or can get supply, how many houses by one feeder. So there might be 50, 60 or maybe 100 and more than 100, depends on these two conditions in one substation. And you have in that zone or block, you might have 10, 20 substations. Or if you are dealing all data together of a area or of a country or of a region, so you can understand that what would be the volume of the network. So in that case, if you will go, if the volume of the network is high and you will go to proceed this job manually, so it will take a lot of time, as well as, if you will draw manually, then there are some chances that anyone can make mistakes. So there will be some mistakes like undershoot, overshoot. These are all geometrical errors, and happens when we digitize or when we make the distribution network. So I automated this process. So the first benefit of this process is, of the automation, is that this undershoot and overshoot problem you will not face. Second, it will save a lot of time. So I will show you. First I will run, and I will tell you also some logic behind the code tool. So first we have to select the service layer, and this is electrical service points here. Then the feeder layer, it is this one, low voltage underground cable. And here service point field, which on which point it will decide that which feeder, which point should be connected to which line in GIS. Okay, in terms of GIS, as you can say that which service should be connected to which feeder. So this field will help us to determine then where it should be connected. So it will build logic. This feeder name, it should be anything. I named this field feeder name. You can name it anything like XYZ or something else. The same, the here, this feeder name, you can select anything. You can name it anything, X, Y or Z or whatever you want. But those fields, those name should be selected here. In service point field should be connected the concerned field from the service point feature class, and in cable field uh, you should select the field that is in LVUG feature class. So this will build a relation. For example, this feeder, substation feeder 4, substation 4, feeder 4, it should be connected here. This 2 point should belongs to either this or either this, because we have to. This 2 point should be connected to this, because we have only one line. But in case of this, because these 2 points, as I said, feeder 1, substation 1, feeder 4, substation 1, feeder 4. These 2 points, we have one here, 2 lines. So where it will be connected, to this point or this point. So for this one, I used the nearest line. For example, for this point, this is the nearest line. For this point, this is the nearest line, and for this point, this is the nearest line. So like this, it will connect here and it will connect here, and that is logical also. Okay, these lines actually in the company, as per the guidelines of the client, we were not using any cable tracer or GPR or anything. So these lines were transferred by using the hard copy maps provided by the client, or by a logical thinking. Logical thinking means here this service is feeded by substation number 1, feeder number 4. So what does it mean? It simply means that here should be passing feeder 4 from substation number 1. The same apply here. Okay, so this by this way, or with the help of hard copy maps also, as I told you, provided by the client, we draw the main cables. These service points were captured by the survey. So I am saving the output here in services GDB. One service is one feature class is already there, so it will be saved here by some name that I named my services or my services one. If you want to know that what is the name, then I have to open the code. Anyway, it will be saved automatically, so that time you can see what is the name. So just I will run it. It took a lot of time, and mostly I tried it a lot of time, and it is taking 2 or 3 seconds, but due to some reason, maybe it took 22 seconds for 4 services. Even it is very less time compared to the time that you will consume while you will draw the network manually 22 seconds. So now I will add the layer as I told you that I am saving in this services GDB. So this is services GDB and I told you that I named my services. So this is my services. I will load and you will see. This is nearest here, so it is connected here, but with the same feeder. Suppose any other feeder is here also, it will not be connected to that feeder because it is connected to. I will show you what I mean. I will remove it. First I will remove it, then I will remove it here. Sorry, I will delete it from here. So what I told that if any other feeder is going here, for example, I will create one more feeder here. And this is I think my system is running slow for some reason anyway. So I will create another feeder and this anyone, for example I will call it feeder 1 but sorry substation 1 but feeder 5. So as I told you that behind the tool there are two things, one the feeder name, the same feeder name, second is the nearest. I am calculating. Now I will run it again. So here the service point layer, here the LVUG underground cable, here feeder name, here feeder name, and you run it. So this time 4 seconds it took. Just I will close it and just my services again I will load it. So you see it is not connected here, while two feeders are here, but it will filter out, it will select only the filter that is based on the attribute relation. So I will post this tool on the comment box, the link of the tool in the comment box. So download it from there and use it into a different way. Use it in a dense network like this network I created for the demo purpose. I cannot use any other data, just demo purpose I created this network. You use it on your actual data, and it is not necessary that it is applicable in only electrical distribution network. You can use it in any network. The two things are main, that it should the attribute relationship means not relationship in the form of table, or you have not to define any relationship in the database, but there should be one feed in service point, one feed in cable feeder that should have the common value. For example, this substation 1 feeder for substation 1 feeder for like this. Thank you.